free, so they're all over expensive. So in doing this, there is this issue here which local government, every government has to give some consideration to in relation to climate change impacts, but they already do it for other things now, and that is to work out what is the acceptable level of risk. You know, how chancy are we willing to be? This analysis, we've worked out the costs for only protecting existing developed stretches of the coast. That's where there's infrastructure being protected by these beaches and private property. This is the real world, though, and this commonly gets left out. By the time climate change becomes an important thing, of course, life will have moved on. Much more of the coast will be developed. In fact, if the government's policy at the moment for development at all costs as fast as possible, it's good for business, good for jobs, all the things that everybody cares about. If that happens, well, by the time we get to 2100, the whole coast will be developed. And so, if we adopt a 50% risk level of acceptable risk, this means that we've got a 50% chance of being wrong as well. So this might correspond to what we would consider being the best guess. It's right in the middle. Well, Jeroen's work shows that it would cost $3 billion by 2100 to add the sand to the beaches, provided that we can get at it offshore. The risk, well, I'll talk about how these risk levels arrive, also takes into effect that maybe we can't get it offshore, and there is some uncertainty pertaining to the cost of sand. However, a better figure is for this 50% level of risk, something more like 8.5 billion, because there will be more real estate to protect by then. If we take a more prudential approach and say, well, we actually care more about our children and their children, and so we should be patriotic enough to take accept a lower chance of being wrong, only 10% chance of being wrong based on what we know already, well, the numbers go up. And if we're ultra-patriotic, you know, a bit like the diggers who went to Gallipoli and died for their country, if we were concerned to do the same level of patriotic self-sacrifice, and we're not quite the same, but we're willing to put in a bit more for future generations. So we would accept a 1% chance of being wrong, that we spent this amount of money, it still wouldn't be enough, then the number gets quite large. Pretty impressive amount of money, but it is 2100 we're talking about here. Just to remind you, we live in the sea change society, fast-track development, so we expect the purple list to be the list that's relevant here. We've already made this colossal investment in protecting ourselves against our own stupidity. 40% of the coast is actually locked up in reserve land, so as long as that stays the case, we don't have to worry about that. Of course, we'll lose a bit of biodiversity when the coast erodes, but that's just nature in action. To translate this into something that Frank Sartor's best mate, Michael Costa, understands, Michael's actually the man you have to appeal to here, right? What does this mean now? What's this mean for the current budget? Under a maximum growth policy, which is the one that New South Wales operates, well, again, we've got this acceptable risk, and we're talking about future liability. So the question is it going to be funded or unfunded? Is money going to be put aside for this? So at the 50% risk level, this is where there's a 50% chance it's going to be, we didn't save enough. You'd have to put aside $85 million, or you could actually start spending the money now if you're really proactive. If you don't spend the money now and climate doesn't change and these impacts don't ensue, then you know, it's like a future fund, isn't it? We've heard about that as a strategy for the future. 10% is 150 million. You see these numbers relate to the previous slide. 1% is 220 million bucks a year, which it's not a lot of money, given that we buy aeroplanes that don't go very fast and so on for $20 billion for now. So it's not a lot of money to invest in. But if we have to do it for everything, I mean, this is just for the sand to protect the beaches and protect properties. If it's for everything in the coastal zone, Jeff Withercomb's long list, much less everywhere else, you know, it adds up to be a lot of money. And this is why we need a national audit, or a state audit at least, that actually can deal with this. Okay, well, those numbers that I've been citing have just been plucked off a risk curve that looks like this. Down here is the probability of being wrong, essentially. So down here, if we say there's a 0 probability of being right, then we can go with the idea that we won't spend any money. So it doesn't cost much. If we go up to 50% chance of being right or being wrong, that's where we get our best estimates, and we read across on the risk curve, and that gives us the 8.5 billion. If we go right up to the 1 in 100 chance of being wrong, so 1%, very responsible thing to do, then we simply have to be investing more money by 2100. We can generate this through modelling. We have to use a model that not only makes one prediction, most of the time we run models that just give us this, give us that number there. But if we run the model time and time again, and we put in different estimates of future sand cost, different estimates of how the coastal processes operate, and of course different estimates of how much sea level will rise, because the IPCC gives us a complete gamut of these things, then we can run the model many times and produce this probability distribution. This is the same thing, different experiment if you like, but in this case, if there's no offshore sand extraction, everything suddenly becomes a lot more expensive at each level of acceptable risk. 38 billion at the 1% level of exceedance. Well, that's in theory, and this is based on if there's no offshore sand extraction, we'll be paying $20 a cubic metre in present day terms, as opposed to $3.50 a cubic metre for the sand that we put on beaches. But it's a bit artificial anyway, because the $20 comes from friable sandstone and out of the dunes and so on. If you want to build something, you know that that's what it costs to be delivered, and there's not enough of that sand to do what